Hi, my name is Steve McKinney. I'm a marketing manager for the Hyperlinks analysis products. And today I'm here to talk to you about power design issues in your PCB. Specifically, I'm going to be talking about DC drop analysis and why we need to be focused on doing analysis of power design on the board. If we want to understand why it's important, we need to go back to the IC design trends to really understand what it is that's driving the need to perform this analysis. If we go to the IC design specs and look at some of the trends that are happening, one of the things that's happening is that the voltages of the ICs has been going down. So as the voltages go down, the tolerances that you have on the IC begin to go down as well. So as the tolerances become lower, it means that you have less margin in your system to be able to address potential issues. Another issue is the density of the boards. As densities begin to increase on the PCB, it creates more perforations in the power planes. So you have all these little perforations in the plane which are reducing the amount of copper, and that's all from the vias that are in the design. So you have less copper that's supplying the power to the IC power pins. So this presents problems specifically with DC drop or IR drop. And with IR drop, what we're trying to do is understand how much voltage drop from a VRM or voltage regulator occurs all the way through the plane cavity to the IC. So in order to understand that, we could do some hand calculations, but as I said, as these vias begin to perforate planes, it's a lot more complicated to understand how much copper you really have in your board to be able to supply that voltage and the current. Another issue with these perforations and neck downs that causes a problem is we end up with increased current densities. So as the current goes up, it means that we also have increase in temperature. This presents a difficult problem because we need to understand how the current density is impacting the thermal properties. One of the new capabilities in Hyperlinks is the ability to do a co-simulation between our DC drop analysis and our thermal analysis. So what happens is we run through a DC analysis, determine how much voltage drop occurs, what the current densities look like, and then run through a thermal simulation. From that, we can determine how much increase in resistivity occurs because of the thermal behavior on the copper. So DC drop is designed to help you identify the issues in your board related to the supply from the VRM down to the power pins on the IC. We can identify issues related to current density, as well as being able to find problems supplying that voltage to all the power pins on the IC. In addition to that, Hyperlinks has the ability to do a co-simulation between your DC drop analysis and then thermal. So we can really understand the behavior of the whole power distribution design, as well as the temperature rise in the board due to that design. This is important because when we look at the current densities and it necks down on, let's say, 1 volt plane, and the current density increases, that's going to cause a temperature rise in that region. And so we can run analysis between DC drop and Hyperlinks thermal in order to get a much more improved result that captures all that information in the analysis. And in the end, you're going to get a much more realistic simulation that's going to mimic the behavior of the actual system. So just to summarize, we've got 3 different things that we've talked about. We talked about power distribution design and looking at IR drop or DC drop, going again from that voltage regulator down to the IC, supplying adequate power there. Number 2, looking at the current densities within those planes to make sure that we don't have issues that are going to result in number 3, the temperature rise. So Hyperlinks PI, along with Hyperlinks thermal, can help you address all of these issues. If you want to find out more, you can go to mentor.com, and there you'll find information on the Hyperlinks PI tool. Thank you for watching.